One more rule of differentiation I want to go over, and that's the inverse function rule. Suppose y is a function of x. Then we know for each value of x, there will be a unique value of y. But you might be interested in asking the question, okay, y is a function of x. Under what circumstances will x be a function of y? Okay. You might ask this, does this function exist? And this is called the inverse function. X equals f with a -1 superscript of y. And I'll put question mark. Because just because y is a function of x, that doesn't necessarily mean x will be a function of y. The only time it will be is when the function is said to be 1-to-1. If for each value of x there's a unique y, and if for each value of y there's a unique x, then the function is said to be 1-to-1. For each value of x there's one and only one value of y. For each value of y there's one and only one value of x. And the function is said to be 1-to-1. Okay. Now, these 1-to-1 functions are unique to the class of monotonic functions. So I know this sounds kind of very abstract, but a monotonic function is just a function that's always increasing or always decreasing. So there are two types of monotonic functions, monotonic increasing and monotonic decreasing. For a monotonic increasing function, say y is a function of x, then this function, f, is a monotonic increasing function of x if for all values of x1 and x2, you pick two different values of x. Let's say if x2 is greater than x1, for any two values of x, you pick any two different values of x. If x2 is greater than x1, if that implies that f of x2 is greater than f of x1 for all values of x1 and x2, if that's always true, then it's a monotonic increasing function. Then f is a monotonic increasing function. Okay. If, on the other hand, if x2 is greater than x1, that implies that this is the other way, then it's a monotonic decreasing function. Okay. This may sound kind of abstract, so let's just take some simple examples. The case we considered just earlier was this. 10 plus, actually I'm going to change it. We've considered this one before. Let's make it easier. 10 plus 2x. Instead of 10 plus x squared, let's make it 10 plus 2x. What kind of function is that? Adam? Linear, okay. In terms of monotonic, what would you guess it is? Yeah, it's a monotonic increasing function. Because it is a linear function with a positive slope. So that means as x gets bigger, y gets bigger. And that's always true. So this is an example of a monotonic increasing function. If we just look at its graph, it looks like this. It's 10 plus 2x. So it looks like this. It's a linear function. You could see if we just pick any two values of x1 and x2. Here's x1. Here's x2. The bigger the value of x, the bigger the value of y. The bigger the value of the function. So this is a monotonic increasing function. The bigger the value of x, the bigger the value of the function. Okay, monotonic increasing. Now, what would be a simple way to change this function so that it's a monotonic decreasing function? Yes, Patrick? Yes, let's just change this from a plus to a minus. Now it's a monotonic decreasing function. And its graph would look like this. Now you see when x gets bigger, the y value gets smaller. And that's true for all values of x. Okay. It has to be true for all different pairs of x1 and x2. So if x gets bigger and the function gets smaller, then it's a monotonic decreasing function. That has to be true for all values of x. Okay. Now, what would be a simple way of testing whether the function is monotonic increasing or decreasing? Yes, Lucy? Yeah. Yeah, find the derivative. If the derivative is always positive for all values of x, then you know it's a monotonic increasing function. If the derivative is always negative, then you know it's a monotonic decreasing function. So that's the simplest way of establishing whether a function's monotonic increasing or decreasing. Okay. So in this case, f prime of x in this case is always equal to what? Anybody? Lucy? Oh, in this case right here, -2. And that's -2 for all values of x. So this means it's a monotonic decreasing function. Okay. For y equals 10 plus 2x, then the derivative is always +2. It's always positive. That means it's a monotonic increasing function. Okay, so linear functions are easy. Easy to establish whether it's monotonic increasing or decreasing. Okay. Just take the first derivative. What about this function right here, the one we did in class? Is this a monotonic function? It's not monotonic. Because in this case right here, if you look at the first derivative is equal to 2x. Now, in order for this function to be monotonic, the first derivative has to be positive for all values of x. That's clearly not the case, because suppose x is negative. Then the derivative is negative. X is positive, derivative is positive. So this function is not monotonic, because the first derivative can be positive or negative, or even 0. So it's not monotonic. And actually it makes sense, because if you look at the sketch, what is it? It's a parabola. And you can see, just by looking at the sketch here, it looks like this. In this region here, y increases with x. In this region here, it's decreasing. Okay, so this function is not monotonic.